for this next phase, we're officially kicking off the thought leadership track of the day, entering into that next phase. And to kick us off, we have a very special guest with us, David Aronchek. Hopefully I said that correct. David is the creator of Kubeflow,
Oh,
co-creator of Kubeflow,
can't take all the credit or blame.
but we're very happy to have you. And is currently the CEO of Expanso.
Yep,
Wonderful. I'll let you kind of describe, I guess, what Expanso is, and then
absolutely.
take us away.
Absolutely. Hi, everyone. Thank you so much for the opportunity. I do love talking to folks, about AI and ML and so on. Obviously, I was really excited about Kubeflow. You've heard me like attempt to stay out of it because it's been so long since I've been involved, like as a first class citizen. But it's extremely exciting to see how far it's come, and I really feel fortunate to be able to chat with you all. Um, I'm going to give you a talk today about ML and AI and how things have not progressed. Everyone's looking for the like amazing future looking stuff. It's actually kind of funny. Like I'll go into it in a little bit. The question about what I'm currently working on. So you all are familiar with Kubernetes. I love Kubernetes to death. I was the first non-founding PM for Kubernetes before I started Kubeflow. So I was really, really involved and I still love it. Absolutely. But it is built for a very specific use case. And that's where everything, your entire data center, your entire data, your compute sits inside a single zone, inside a single data center. The moment you do anything outside of that, cross zone, cross region, cross cloud, there's a big gap because it's not built for that. That doesn't mean it's bad, doesn't mean you throw it away. It means you need an additional tool or additional platform that takes care of that. And that's what we built. So I co-founded a new project called Bacalhau. I should write it down because no one knows how to spell it. It's Bacalhau, which is an open source project designed to really give you a Kubernetes-like experience, a declarative workload, but one that runs cross zone, cross region, cross cloud as a complement to your centralized Kubernetes or Databricks or Snowflake or whatever. It makes it much more efficient to process data, to run ML jobs in all those places as an augmentation. Expanso is the commercial company that supports it, and we help bring it to market and so on and so forth. The code is open source, the binaries are commercial, and you get those from Expanso. So that's what we do. I'll get into what we do in a little bit more detail a little bit later. But I promise, actually, I was quite serious about not presenting a new deck. So this deck, everything you see here is unchanged from 5 years ago, and which is like ages in ML space. But this is totally true. Last week, all the DeepSeek stuff came out, and I was like, everyone's freaking out. I was like, there's nothing new here. There's nothing even a little bit new, right? We knew about everything years ago, and funny enough, I'm not a very, what do you call it, arrogant, narcissistic person, I promise. But I posted a talk I gave 6 months ago saying, hey, by the way, this DeepSeek thing, this is the way it's going to go 6 months ago. And you can go, I posted it on my LinkedIn, you can go look at it. Me standing on stage, hey, by the way, this is not going to work forever. Here's how it's going to break down. And, I'm not a fortune teller because look, this is 5 years ago, and I was basing this on even older research, right? So we're getting into this. I promise. Nothing new here. And you can see right there, I'm talking about Kubeflow because I really like Kubeflow. It's great. This, by the way, is me giving this talk. You can see my hair there because it's like COVID and no one can get their hair cut, right? And this is me in my house. Just to prove to you, there's nothing new. I was giving this talk at KubeCon 5 years ago. So I start by saying, like, look, ML is hard. Everyone's like, oh, so excited. ML is great. ML is great. No, ML is kind of hard, right? And you're like, well, why is it hard? And it's because everyone focuses on this, right? Which is fine. It's a perfectly good thing to focus on, except when you're actually building ML, it looks like this, right? You have all of these additional steps around it: data ingestion, transformation, validation, splitting, training your model, so on and so forth. Now, most of you probably aren't going to face the majority of this. You may use a pre-built model or one that's already a foundational model that you're fine-tuning on top of, which is fine. By the way, your thing still looks like this, except you start at the upper left there with a model. instead of nothing. But you're still going to do all of these steps. And so many people forget about these steps. But this is where, everything you were hearing about earlier, whether or not it's Kubeflow or another pipeline, this is what a pipeline looks like in detail. And you say, okay, I'm a data scientist. I don't care about this, right? But yes, you do, right? And the reason you do is because of what you were saying earlier about ML ops, right? Everyone looks at this thing over this big circle over here as like, okay, that's my ML, and maybe I do a bunch of iteration. You leave off all of these other things, the DevOps part, right? How do you train it? How do you roll it out? How do you get it into your CI, into your app? How do you operate it once it gets out there? What's the loop? How you're collecting information and feedback in order to make your model better? Again, nothing new. We heard about this for years. This is like the way it goes. And in truth, the DevOps portion has been probably 10 years at this point, right? It's when first advent of Kubernetes is when people started talking about how do you take responsibility and so on around DevOps. And then a bunch of smart people are like, oh, well, let's add ML to the front, right? Which is true. You add ML because ML is just another application. Don't treat it like a special Snowflake. It's just another application. And you get a bunch of benefits, right? If you get into the ML pipeline, you get this, right? You get observability, you get validation, you get this really critical thing around reproducibility and auditability, which again is one of the biggest missing components here. When you get those black boxes that we were talking about earlier, how do you actually know what went on? How do you know what data went in there? There's all this kind of stuff. But what you should be aiming for is that thing at the bottom, right? Velocity and security, right? That's what you're trying to do around ML, and ML ops helps you get there. It's not a panacea, but it helps you get there. So then I used to give this talk a lot to a lot of folks about security, and that's what I'm certainly going to talk about a little bit here. And people are like, well, what isn't this talk supposed to be about security? And my supposition to all of you is that ML ops is the baseline for security. If you want to be secure, if you want to be reliable with your ML, you need ML ops. And I'm going to explain why. And then you say, well, it's just math. How bad could it be? But now I'm going to talk to you about some of the attacks, okay? And the way that your ML models are at risk and why you need to be able to update very quickly and in order to be secure. And this is, again, just shocking. No changes to this presentation. Nobody listens to me, right? But no, again, not me. It's like all the people that came before, right? So we're gonna get to these three things here about how you get your ML model to lie to you, how do you do when an attacker takes your model, and then how does you do when an attacker finds out about hidden data? Okay. So first, how do you get your ML model to lie to you? Okay. So we're going to start with what an ML model actually is and what it looks like and how it works. You start with your ingestion, you talk about there, you take your data and then you engineer it, you split it into various sections. You then train your model, you'll have a test thing, you'll have a test data, you'll have training data and test data. You always should keep them apart. I promise you, like if you haven't trained models already, you will have leakage. This will be the first place that you're like, my model's training great. And you're like, no, it's not. It's training on test data. That happens all the time. Then you finally train your model and you finally serve, right? Everything you talked about there, Knative and all that way of getting it out and serving it. So the way you approach building a model is you stick a bunch of stuff into your training data and your test data, and then you serve it. And you say, okay, well, this came out, it had great results. What actually happened? And you present it with a circle on a big white sheet of paper, and it says, hey, great, it's a circle. And then you do it again. You're like, white piece of paper and square, and it says, well, it's a circle. And you're like, what the hell? And it turns out your failure usually is that you didn't get enough negative training data or other things like that. Because your model doesn't understand anything. What it understands is it's just doing pattern matching. It has a bunch of characteristics about the thing it's looking at and says whether or not it fits the characterization or characters that it already knows about, right? So in this particular case, hey, that circle has the exact same pixels that the square does. It doesn't know that it's like those are extraneous things. The little corners there are extraneous to being a circle. All it knows right now by default is that if it has a bunch of pixels in there that look like a circle, then great. And as you can see, it's a perfect fit. It is a perfect fit for a circle. So that's your fault because you didn't do this, right? You said, hey, checkbox, this is a good thing. And then this is a negative example. Don't, if it looks like this and it has extra stuff around the side, that is not a circle. And again, I'm overly simplifying it a little bit, but this is basically all ML does. Okay. Now we're going to get into transformers and other things like that where it gets a little bit more complicated, but under the hood, this is what's happening. So you say, okay, well, that's only for simple models. Surely more, as you get bigger, more advanced models will get better. And so here again, bunch of research. This stuff came out. All you see at the bottom of this, the links to all the papers. You can go look up the papers for all these things. Here you have this amazing model that goes out and detects whether or not something is a wolf or something is a husky. Okay, amazing. And look at this. 5 out of 6, pretty good, right? Well, then you get into what's called explainability. And explainability is something which had a lot of momentum, in the late 2010s, early 2000s, kind of is like lost momentum, which really bumps me out. It's really, really important because what it does is it tells you this. So what explainability does is it says, okay, here's my measure, here's my output, how I'm going to bind the result. And here were the pixels that fit into this. In this particular thing, this is an image one, but explainability does this a lot. And what you're looking at there is, what do you see, right? The gray pixels on the right there did not affect the decision as it came through. And the clear pictures does. Does anyone see what this is actually detecting? Anyone want to say out loud? No. Snow. Exactly right. It's detecting snow. It's not detecting these wolves at all. But it just so happens that wolves happen to be in the snow, right? So there you go. And this happens all the time. Congratulations, you have a water detector, or you have a tracks detector, or you have a copyright notification detector, right? Like, it's just, this is what happens. If you don't explain your models, if you don't dig in to why you are getting the results you are, you're going to have a bad time. And this kind of stuff will happen all the time. And of course, then you get all these like super things. And again, this is stuff that's like whatever, 5 to 10 years old at this point. Here, for example, it's detecting chicken as nudes, but if you add an owl there, this was it actually happened with Tumblr. Went through okay, right? So it's detecting for skin color. Here's where you get into some really interesting stuff where you start to get to what's called adversarial inference, where just by putting pixels in certain configurations over the image, you are able to get it to lie. So on the left-hand side here, that's a real stop sign, and they put stickers over it, and we're able to convince the model that this was not a stop sign. In fact, it was a speed limit sign. So your auto self-driving car would just drive through. On the right-hand side, they applied a mask to the back of this turtle, and they were able to convince it that was a rifle. Right? Now, again, do we know exactly why? No, but like it's just enough to cause the model to lie to you, and you're going to get this happening over and over again. What it's your job to do. Oh, and here's one more in a military context. They applied stickers to the back of these airplanes, and were able to hide the airplanes on the roadmap. And then you had this. That's Jeff Dean up there in the upper left. This is a team out of Google where they made Jeff Dean look like Linda Evangelista and so on, right? Just by applying these glasses over their face, right? So again, it's one of these things where this is not new. We know about this, and the problem is that as we're using ML as more and more of a black box to just detect these things and whatever flag people at airports, you're going to have a lot of bad things, and you really don't have a lot of options to wait out. Now, I just flew here, as you mentioned, I just flew here from London. I didn't scan my passport. I didn't do anything. I just showed up, and it took a picture of my face, and then it waved me through, which is kind of insane, but it's fine. It made me get through fast. But like, I have no idea what that black box model looks like. I have no idea how they're matching me. I could have easily been flagged as someone very bad.
Yeah, husky.
As a husky, exactly. So, are you terrified yet? So, the truth is, there are many, many tools to defend. Okay, You can test for edge cases. You can look at bad data. Again, you can be very aggressive with yourself and red team yourself. I very strongly do this. For those who don't know, the term red team is like have a group of people attack your own models. You can get better evaluation metrics, lots of different models. And one of the things is that lower right around like alerting and monitoring is so critical. Like you have to be faster at detecting what is going on and what's not. And that loop of taking that feedback back from your root model or from the thing being served in public back to the original is critical. You have to set up a pipeline to do that. And the key here is all of those tools only work if you are able to take feedback as fast as humanly possible, put that back into the start of your pipeline, and then repeat and do it again and do it again and roll out new models and roll out faster, constantly be rolling out. The best organizations in the world roll out daily or more frequently. It is that critical because I'm telling you, you think that model is working and it's going stale way, way faster than you think. Okay. Any questions so far? Okay. So pipeline, tell me more. I mentioned previously, to use, Kubeflow is amazing. Models go stale quickly. Don't let your adversaries be the ones who notify you. That's critical. Okay, so that's one. Get your ML model to lie to you. Two, your attacker takes your ML model, right? Which is very, very, very relevant. So how do they take your model? So one of the most important things that they will get out of taking your model is the fact that they get private access. Why do they need that? Because doing adversarial attacks, like I showed in the first one, require an enormous amount of probing of that model. And so you need to know every bit about your model, like how you can attack it, what works, what doesn't, the response rate. And if they're having to do that against the public API, you can defend against it, you can detect it, things like that. If it's against private, they can do a lot more and a lot more probing and things like that, which is really hard. You can get mostly correct performance. You can even replicate, and as we saw, as I'll get into in a second, you can distill and actually serve it as your own in a really positive way. But that's not that critical, right? Any model, the way that ML is moving today, any model that's out there will be cloned in a variety of ways, very, very quickly. Certainly under a year and probably less than that at this point. But it really gives it that foothold for attacks down the line. That's so brutal. And that's where you have to be aware of that. It is also very, very hard to defend against completely. Very, very hard. And I will get to that in a second as well. So there are two main attack avenues. This may be the one slide that's probably out of date. There are probably lots more attack models. I haven't done the research on what's working, what's not. But these two are the biggest ones. One is called distillation attack, which you heard a lot of people talking about DeepSeek as being a distillation attack effectively. And I'll get to how that possibly worked. We don't know. It's not really a distillation attack because they didn't need to, because there was already Ollama out there for open source. There was always Mistral out there open source. They could have easily used those as baseline models based on their licensing and things like that. But again, we don't know for sure. And based on the quality of the paper and the team that they put together, they really did come up with some novel stuff. So I don't think it is by any stretch just them cloning what was out there. The other one is a model extraction attack, and I'll show that as well. So distillation attack. Okay, so first, again, let's talk about how you build a model today, right? I have a model that I would like to, I actually don't know what it does. I don't know the size and the shape of exactly how it works. All I know is it's a black box. Now, again, you would know a little bit more as you get started. But what you would typically do is you would start showing it examples. So what we're going to do here is we're going to walk through a distillation attack. What you do is you hand it something, hand it an example, and then you see whether or not the example worked. And you basically map that example into a vector space, and you say, okay, I showed it a heart failed. Then I show it something that looks like a house, and it kind of worked, right? And then I show it lots of examples, and I begin to kind of get a formulation on like what works and what doesn't against that model. And then I show it a lot more examples. And eventually I get to this. And I'm like, wow, look, that model is a triangle detector model. Based on what I showed it, here's what worked. And again, this is overly simplified, but it's roughly correct, right? And I joke, it's the Nina Simone model. No, it's an actual triangle detector model, right? Which is great. But now what have I done, right? I basically said, here with all these examples, it now predicts triangle. So now I can use those examples as the root for me building my own model, right? Because now I've reverse engineered the minimum necessary for me to understand, to build a model like this, which I now duplicate. And now I can serve that model to myself. They never have to go to the original model. Make sense? So now you're like, okay, yeah, go ahead.
So essentially, using their original model of the labeling concept.
Essentially. Exactly right. Okay. So anyone want to guess like what this cost to do to get to 99% accuracy? Well, there are a bunch of papers on this. In this particular one, in order for me to get to 99% accuracy for a digits or adult recognition against Amazon's logistic regression model or Big ML, I don't even know if they're still in business actually. Again, this is in 5-year-old deck. Doing a decision tree, it was like on the order of a couple of thousand queries. That's it. That's like one query a minute over a week, and you've got enough. Like, it is so small that you could never defend against it. You probably get random probes from DDoS attacks far more frequently than this. It is easily hidden in the noise. So in this particular example, queries to get to 99% accuracy under 5,000. There is no way you can defend against this. No way. Now, it's not 100% accuracy. It's still off, but it's really good. 99% is really good and certainly a baseline for doing a lot of work. Now, that's a really simple one. Let's get into something like LLMs, right? Around BERT and the transformation, bidirectional transformation models that you saw that ended up becoming what you see with LLMs today. This is the background or the background behind most of the APIs that you see out there. Certainly all the major ones with OpenAPI and Claude and so on and so forth. And the way you get at this is through what you see the following. So here you have Squad, which is a Stanford questioning answering data set, where they simply are using this as a way to test how to look at ML models and whether or not they understand. And in this case, again, this is very old data, it's certainly in the ML space, but it still applies. Here you have a paragraph from Wikipedia, and you say, and then you present a question, how many instruments did Prince play? And they say 27. And so this implies that the model is able to understand what is going on in the paragraph of text there. And it's able to pull that out because it has to understand that a guitar is an instrument, a drum is an instrument, so on and so forth. You know, they're able to like pull all this together. It also, you know, what's closed, what's not closed, so on and so forth. You get the idea. So the way to extract this is really fascinating. This is research from Google, UMass, and others. And the first way to do the attack is with random. So here you apply just random words and you try and attack the model, right? So you say, okay, model, here's a sentence. Give me an answer. Now, the model doesn't know that these are random words. It's not actually processing on that. It does an NLP translation into some vector space and then goes from there. It's not really aware that this is a poorly formed sentence. It's just doing its best. So it will come back with an answer. Now, you've presented it with the random stiff, and then you go and get an answer out, and you're like beginning to understand. Eventually, if you do this a billion times, you're going to get a size and shape of what the underlying data set is and the weights and so on and so forth. And you get there even faster if you know what the original corpus is, and then you present, again, still random words, not a real sentence, but from the original corpus. You can get there even faster. And you do this just by getting the answers presented on the random stuff you presented originally. Make sense so far? Now, in order to do this, right, you're like, okay, how realistic is this? Well, it turns out that if you present about whatever, 1 times as many, if you present 1/10 as many words as in the original corpus, you're able to get to, as you can see there, against that squad question answering, 72% accuracy. And if you present 1 times as many, so the entire corpus of Wikipedia, again, not in any structure. This is just random phrases strung together. You can get to 86% accuracy. 86% of the original model simply by presenting random words. It's crazy. So it's like, again, people are like, how did DeepSeek do this? I have no idea, but it's not like there aren't ways to do this. Okay. There is, again, 5 years old. 5 years old. Here it is. Go read the paper. And it's extremely cheap. As you can see there, if I was, cloning a sentiment analysis, I can do it on 67,000 sentences. I can get that anywhere, right? If I was to do speech recognition, $340 or $430, excuse me. Translation queries, each with 1,000 characters, not $2,000. Nothing, right? So it's not like there aren't ways to pull this stuff out today from existing models or 5 years ago, right? Now there are ways to defend. You can like inject a bunch of things. A lot of people are like, oh, DeepSeek definitely cloned it because they were able to probe a DeepSeek model or the DeepSeek model and like get it to respond in the same way OpenAI did. And they're like, oh, they probably did something there. Maybe, right? Because lots of people are publishing what OpenAI is responding to. And so like maybe it's just sucking that in because that's out there on the public web. So like, it's not that, guaranteed. And again, you have Llama out there, you have Mistral, you have lots of very good models, even from a year ago, that are great models and are open source that you could base on top of. And so what I like to say is like, look, if you really need model security, treat accessing your model like accessing your source code, like accessing your API and so on. But honest to God, it will be stolen. It just will. There's no way around it. Stop trying to pretend it's not going to be. And what that means is the value of your model is not in the model itself. It's in your ability to update it and respond and be specific for your industry. Because that is the only constant is change. That your model will change constantly based on new data, based on time of year, based on whatever. And even then, honest to God, you probably have, 5 years before we have like world models that represent everything that never need changing. I don't know. But like, well, you're not going to have a business model based on models. It's just not possible. It's like having a business model based on, I have no idea, regex or something like that. It's like, hey, you know what? It's out there. There's everything. Okay. So then we get into the final thing, which is your attacker finds out about hidden data. Again, this is something I think is really underplayed right now. We're probably going to see more attacks on this because the space is so big and there is so much data wrapped up in these models. But there's lots of like really famous, terrible data leakage examples. This one's from Waze. And this is not from Waze. I'm giving you an example here. I don't want to like throw anyone under the bus, but it's like where you pop open your app and it says, hey, you know what? You're going off to a unionized meeting. Maybe it's in the network graph. So in Twitter, you go and it knows who else I should be following, right? That's signal data that's leaking out, and other people will be able to look at who it's recommending to me. This is an actual one. This came from Strava. Strava like would watch people and how they like where they ran around military bases, and they were able to map out the entire military base because they were leaking the data. So lots of stuff there. And I like to joke there's nothing so bad that can't be worse, especially with ML. Again, this is basically this for all things in computing, there is an XKCD for it. Here's the XKCD. If I go into Gmail and I type the first part of a sentence, and it fills out the rest, maybe I identify me as a communist. Who knows? Because of all the other communist stuff I wrote. So does that mean that that model now contains it? Now, again, how does the attacker get at that? Well, it's not going to be terribly easy, But this concept of secret memorization is a really big thing. And if it can pretend to be me and ask the model a bunch of questions, it's probably going to leak a bunch of stuff. It just is. Now, pretending to be me is not a terribly easy thing to get around, but it's also not that hard, right? So you could get my address, you get my phone number, relationship info, et cetera, all based on pre-built things. And there's again another great paper on this from Berkeley and Google Brain and others. There's some really interesting ways to actually probe your model about this. So you inject some random canaries and then later you test for the canary. It's really kind of creative stuff, and you should go read the paper about it. And there are interesting ways to get at it. They have some concepts around differential privacy. This is a big thing that again, I'll get to in just a minute because it is very pertinent to my business. But it's the idea that, hey, instead of ever moving the data into a centralized location, let's leave the data where it is and never have centralized things. So one way of doing that is around what's called differential privacy, where the only it's not encrypted, it's really the weights of my training data goes into the training data rather than the raw data itself. And theoretically, that's more secure. I suspect in the time since I did this paper, there were ways to unpack the weights, but I don't know what that is. But it should help. So I hope I've made a convincing argument that the right answer is a pipeline of some kind. And the question is, how do you build one? As you saw earlier today, we talked a lot about Kubeflow as a wonderful way to do this. I would argue you need many of these things, many of which, or most of which, are now provided by Kubeflow right out of the box. When I wrote this, there was a lot of the customization that you had to build around this in order to get it right. But as it stands right now with Kubeflow pipelines, you can do a lot of this stuff right out of the box. We just saw even this week. You mentioned about Feast coming in as a default feature store. That's really exciting. Having a model registry, having all these things is incredibly important. One thing I'm going to call out here is everyone tosses serving over the wall. And this is where we get into my business. So I talked about Bacalhau. I talked about how it provides a compute over data platform to do a lot of really interesting things. One of the things we do see very frequently is using us for serving. Why? Because it turns out that hosting your API, hosting your entire model behind a single API in a single location, not so great. It's slow. It's very costly from an compute perspective. Trying to maintain lots of queries and various things like that in a single location can be extremely expensive. And to do that out there on the edge, near where you're sucking in video, near where you're sucking in log data, all that kind of stuff, far more efficient. Strongly recommend. The fairy tale I like to give around this is the following, right? You have a kind developer and she's out there saying, hey, the model looks great. SRE, take it and run, right? How hard could it be to roll this out? And she is very angry about this. And the reason is because rolling out models globally is very hard. Now, I went on to Blue Sky and I asked people about rolling out models. What problems have you seen? And this doesn't even capture everything, right? It's just a million things. It is so hard to get this right. The number of ways you can fail is very, very large. And even if you roll it, then I like to say, or it just doesn't work for no discernible reason, right? What does that mean? Does that mean you should not do it? No, because you should figure out a way to fix it, right? That whole move fast and break things, which sadly has gotten some negative stuff recently. It actually is, there's a really good reason behind it. Because the thing about it is the first words there are move fast. That's what you have to optimize for. Moving fast. Don't work yes, attempt not to break things, but you will break things. So get into a position where you can simply roll forward to the next thing. And some people are like, all right, you know what, distributing to all these places is too hard. Instead of that, let's build just a giant machine. That'll solve all our problems. And our SREs even matter, right? Because it's still hard. Everything you saw there already exists, except now you have all these other problems whether or not it comes to before moving your data, whether or not it comes to after moving your data, like all of that is a problem on its own as well, right? So the net of what I'm trying to get at here is, there is no silver bullet here. The best thing you can do, and it is also not a silver bullet, is don't look at your infrastructure, look at your users, look at where they are, look at where your data is, and do things in place. Don't think about trying to centralize as the solution here. We went through this massive pendulum shift in the past, whatever, 5-10 years, around incredibly powerful and useful platforms. Snowflake and Databricks and Mongo and all these things. I keep using them. They're great, but they're not a panacea. Your data does not exist inside a single data center in Iowa. I'm sorry, it doesn't. Your business is global, or at least multi-zone, if you're even remotely responsible. Get to a place where you can do things as though your data was in those places, and then use the centralized data warehouse for what it's built for, like being the final last resort. And I know you say you're very smart and you can solve all this by using Bash. No, I know how to distribute my workloads. I know how to do this, except if you have a bad network connection, or it's slow, or you want to know if it's running, or you want to know if it's still running, or you want to check the version, or you want to update your model atomically, or you want to use its metadata, blah, 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 blah. Like, you're like, oh, how hard could it be? It's just bad. I just need to SSH in and I can do it all. No, you can't. It's distributed computing. There's 45 years of academic research saying how hard distributed computing is. Do not try and take this on yourself. Use a platform. Now, again, very selfishly, we have a platform that accomplishes this, but whatever it is, it's like cryptography. Don't roll your own. I promise you, the moment something goes even slightly wrong, you will be a very, very sad panda. So our platform, Bacalhau, there's how you spell it. It helps you roll out models where your data is, where your users are, helps you distribute your ETL pipeline, ingest data faster, process data faster, and so on. But again, we're not the only ones out there. Go research, use platforms that make sense to you. And then you get this, right? Your developer, talking about that DevOps, talking about that MLOps, can now describe to the network where she would like her model to run. And then network takes care of it. It rolls it out. It gives her a single API, tells her where it is, tells her how to update it, all that kind of stuff. Your developer is able to handle it. Your SRE is off on vacation. So, summary, your data will leak. Don't wait for technology to solve. Your best bet is to get yourself into a position of having a pipeline that goes end to end, where everything is tied together, and it just isn't. At no point do you just lift it up and throw it over to the wall to the next person. A single pipeline that spans regions, spans clouds, spans data, spans different disciplines. That's your best bet. And MLOps gives you, all these things. It feels like a lot, and I'm certainly not saying you take it on day one, but really you need to be, if you want to be supporting, hundreds, thousands, millions of users, this is the direction you're going to need to build for. And even with that building, even with that technology, it's going to require human and software work. Immutable truths that I said there. The number 3 is the critical one. The game is all about mitigation of harms and quick recovery. And then if you'd like to find out more about our project, we are open source. The binaries are commercial, but the project is open source. Come join us, join our GitHub repo, join our Slack, join our everything. We would love to hear from you. And there you go.
We kicked off the thought leadership track with David Aronchak, and I wanted to take a quick moment to rebase on why we're here and why we cut the event today into 2 sections. The first one with a little bit of training and some hands-on skill development with AI tools and where AI is being used, specifically with managing Kubernetes and those environments. But ultimately, AI is creeping everywhere into our lives, and that's means well beyond just the technology and the tool sets that many of us work with today, but into several industries. So when Ron, Jacob, and I, and a couple of others started to think about, what we wanted to get out of today, was the ability to kind of expand beyond the technical skill sets that a lot of us are used to, and begin to consider how are individuals talking and thinking about AI in different industries. So looking a little bit across the sectors, what we did was we tried to find individuals, not all technologists, but individuals who are having to deal with or work with AI initiatives, as I'll call them, in their businesses, and get a perspective of how they're thinking, how it's impacting their industries, and where it may be going. So hopefully this well-rounded discussion will give everyone some things to consider and think about as they go back to their jobs and think about how to apply AI. So with that, I'd like to. Oh, sorry. Uh, this is intended.
Presentation.
Yeah, I'm sorry. This is intended to be a dynamic discussion. So we will have the speakers come up, give a talk. I encourage questions. So at the end of each session, we'll offer a brief opportunity for everyone to ask questions for the speaker. And more broadly, share your experiences and knowledge as you see fit. All right. We are going to open up with Charles Monk. Charles is with the Internet Society, one of our sponsor for today. So thank you, Charles.
No,
One of the
I
sponsors.
didn't write the check.
Fair enough, but thank you. I'll let you do the
Yeah, sure.
introductions from there.
Sure. Okay. It's great to be back here. And let me see. Yeah. So one of my real day job is actually working in Stanford as a researcher in the Cyber Policy Center. Before that, I've been in the industry, technology, internet industry, and also work in government and a few other things. But that's not important. So today, I'm going to be talking to you about what an overview, very quick, because I should be only given 20 minutes. So I will be talking about the future of AI governance. But first of all, I have to say that things are changing so quickly that are we really talking about the present or the past? Because maybe I'll just stay here. Well, I think when people think about AI in general, you would think that there are two types of people, right? There would be the optimist and there are the pessimists. So the key difference is the people who would probably people think of themselves as the optimist is that everything is rosy and good, but typically the pessimists are more concerned about the risk that AI would bring, and some of them are really technologists that really know their stuff, but on the other hand, I still find that many of these tend to be just driven by their opinions. It's very difficult for anyone to say objectively which side is correct. But having said that, governments, especially because many governments feel that they have had this bad experience with social media. They don't want to lose out this time. Either the politicians think that they better do something because people worried and I should capitalize on that fear, or realistically, some of them you would think back to 10 years. I know my internet connection is unstable. But okay, so yeah, so they always talk about safety. They're beginning to talk about safety. But at the same time, you will see that all these governments are actually competing with one another. Countries are competing with one another to try to, at the same time, get technological leadership. So it's difficult to balance, to say the least. So there are many uh, very data insight. When you look at this whole landscape, these 5 points are some of the things that that I think you should consider, or governments supposedly should be considering. Everybody wants scientific and technology leadership and also commercial leadership in the AI space. They also want to take advantage of some of these data-intensive industry and try to capitalize on the opportunities. These could be financial services, these could be manufacturing, because actually some of the countries that are heavy in manufacturing, especially China, probably had a lot of advantages in this area because they have so much data. So when they train their robots and when they use this to maximize or optimize their manufacturing activities, they have a leg up over many of their other competitors. Even some of them may consider themselves to have better technology, but they have better data, they have more data. But then again, some countries may have a concern about job displacement. I sometimes may come back a lot to China because that's I think many people think that that might be our top competitor. Maybe China doesn't care that much because they don't have enough kids. So their population are dropping. So maybe they don't care so much about job displacement, at least in the long term. Okay, but then again, at the same time, there's this concern about safety. Safety can be things that you would be thinking about, like cybercrime, disinformation, synthetic imagery, things like those deep fake type of stuff, cyber scams, real big problems, and so on. So you would worry that this kind of safety issues, but at the same time, there are also even more serious stuff like military, like using them to make bombs, or whether it would be an adversarial country, government, or even terrorists, national security consideration. So it's pretty complicated. But when we look at some of these legal aspect of AI regulations, everybody is just at the same page. It's just beginning, and a lot of it is actually obviously inadequate. The early legal issues that people tend to think about would be like copyright. So who owns the copyright? If a piece of work is created by AI, that's still, maybe up to the court. But the problem is, obviously, they are using current laws that have no concept of this kind of technology to try to judge on these kind of new cases. So eventually, there will probably be a need for some international agreement on how to deal with this matter, but it's not here yet. Some of the early legal issues are also like stuff like libel and defamation. How many of you have tried to use ChatGPT or any one of them and ask, who am I? Ask your own name. What did you get? Did you get the right stuff? Did you?
Ask my daughter to do it.
Yeah. Well, I tried the first time and they say that I'm a action movie star from Hong Kong. Because they figured out that I was from Hong Kong and they said it must be like Jackie Chan. So the second time I asked, and they suddenly say that I am a politician from Taiwan, because they probably figure out that I am a politician. I was once, and then they say, oh, Chinese politician must be Taiwan. So it all, yeah, it's all these hallucination. I mean, in my case, I probably wouldn't sue them for defamation. At least they didn't call me a rapist or something like that. But they do sometimes to some people. So I want to quickly go through 3 models of regulation. This digital empire concept is or started or written up by Professor Bradford, a Columbia law professor. So she referenced 3 models. The first model, let's take a look at Europe. Actually, the European model is very much based on a tradition of heavy regulation based on human rights or consumer protection. which doesn't exist in this country. So it would build on a series of laws that they have had been putting in as a framework for the whole of Europe, and then local, they in each country they would add or rectified with local laws and regulations and so on. From GDPR, which is like privacy and personal data, which started like more than 10 years ago, and then Digital Service Act, Digital Market Act to regulate the platforms, and then and copyright directives and so on. So after these, they have this AI Act. Actually, the last couple of days or this week, it just came into effect, and EU were publishing the guidelines for compliance. So that's probably the lawyers and people from Google and all these companies are reading right now. So basically, it's a risk-based approach. So they define these 4 levels of risk. So the minimum is like, okay, video games, no real risk, doesn't care, no real regulation. Limited risk, like chatbots, just yeah, doing, answering random questions and so on, limited risk. And then they would look at the high risk and unacceptable risk to try to really regulate them. The high risk would be in these examples, like critical infrastructure, education, healthcare, and so on and so on. You can read. So they would probably require a lot more transparency for these companies to tell them about the algorithm, and they have to answer questions if problems come up and so on. And the unacceptable risk is like simply you cannot do it. Okay. So that's pretty much the framework of the AI Act. And then there's a number of other, typical Europeans, they care a lot about these other issues like training data transparency, which probably has to do with privacy, energy consumption, environmental stuff. This government doesn't, doesn't care about that anymore in this country. So this is what the Europeans are doing. Okay, and then you would have the China model. The China model is basically authoritarian state control, and they typically would have multiple laws. It's not like the Europeans, they have one big law, the framework at least, the AI Act. But in China, they have a whole series of law in the last 10, 20 years, and they keep on adding new stuff to it. And this is part of the whole design. It's like they don't want one single law, but they want many, many different laws that because they do it iteratively, number one. And second, they probably think that this is an easier way to make sure that they can catch you when they want to with many different laws. It makes it easy for them to find an excuse and reason if they selectively choose to do something about it to you. So a lot of stuff about algorithm transparency, actually not transparency, but you have to tell the government, okay? Transparent to the government, not necessarily to everyone else. Deep synthesis is more like the deep fake stuff, or thou shall not create an image of Xi Jinping or something like that. So these are and always, any Chinese communication or law, the first sentence or the first clause would be adherence to the Chinese socialist principle and Xi Jinping's thought and so on. So censorship is like a given. But the reality is this is like cat and mouse because the technology changes. I mean, we'll go a little bit into the deep seek stuff, but actually it showed. I mean, over the last 2 weeks, when people were testing with the DeepSeek example, they had found so many ways to try to successfully bypass the censorship. There are many successful, people who tried it and used different, very smart or some very stupid, easy way to basically get them to answer questions that they're not supposed to answer, like what happened in 1989 or stuff like that, successfully. So remember, well, I guess it also proves that they are trained on many of these data that they, through distillation or other methods, that they basically grab from, ChatGPT. So they are trained on the same data. So they just use sort of a brute force at the highest level to say, okay, if this is some question about politics or it's about the Communist Party, don't answer it. Just say something like, let's talk about something else, and so on. That's typically, if they work right, that is the right answer. But it doesn't work. But it's pretty easy. It's been proven that if people really want to try, they can get around it. So it's actually people thinking about these days what DeepSeek mean to the US. I actually like to think that China right now is obviously enjoying this you know pride of this company being very successful, cheaply creating this model and so on. But actually, they will have their headache later on because it's not something that they like. Then the US, before January 20th this year, we still had the Joe Biden executive order. The reason for an executive order is at that time was because they couldn't pass the law, right? In this country, you cannot pass any law. So the either that you can pass any law, or today it's like he doesn't want to pass any law, so he just do it with the executive order. But in the previous administration, it was similar. So they had this safe, secure, and trustworthy development and use of AI, which was like almost year and a half or 2 years ago. And there were a whole number of guiding principles for federal agencies and so on, because they could only regulate the federal agencies, right? So to make sure that they, with all these potential for wrong AI usage or biases and so on, so they want to make sure that they adhere to a whole series of principles, do a review of these agencies, how they are using AI, and then at the same time encourage them to use AI in their processes, and but make sure that they look at all these risks and cybersecurity issues and so on. But maybe some people would overlook, and I put the third point over here. It's also about research and development, in the sense that a lot of educators or research institutes are complaining that there isn't enough resources, and they don't have the money, to build a cluster of GPUs like these big companies can. Because even if you go to MIT, Stanford, or any of these universities, they're not going to have the resources or the money or the business case of building a cluster of 10,000 or 100,000 GPUs that these big tech companies can. So they don't have it. So they cannot do the kind of leading edge research as they would have been able to do. So actually, the government at that time was trying to build, under NSF, National Science Foundation, a cluster of basically like a big computer, big supercomputer of GPUs for research and development. And then also there are other consideration for companies to self-regulate in terms of safety issues and so on. And then you have a whole series of state legislation, including California, that was vetoed by the governor. And
Why that was vetoed, or what's?
okay, I think that the common our common understanding is that big tech don't want it. So the Democrats, this is a democratic state, right? The Democrats in the state house and Senate pass it. I guess in good faith. I don't have the details to go into the pros and cons of it, but obviously the big tech don't like it. So I guess the governor veto it because of business reasons. He probably doesn't want this to be another excuse for these companies to move out or something like that. So obviously, because the state Congress is still democratic, they're not going to come out and criticize the governor, and they say, okay, we'll go back and do another one. So we don't know what's going to happen. Okay, so the U.S. after the Trump, on 3 days or 2 or 3 days afterwards, Trump revoked that particular EO. So basically saying that this is burdensome requirement for companies and so on. I wouldn't read into all these, but basically he said that, well, we're going to develop something new and make the US AI great again. But and actually, if you go on the Federal Registry website today, you can find actually an open consultation that the federal government, the White House, or it has just started to try to solicit views from the industry or academia and so on for how to regulate it. So in the end, maybe after a few months or a year or half a year, they will come up with something similar, I hope, or something worse. I don't know, but they don't have an idea, but they revoke it first. Okay, this is typical uh, Trump. So anyway, so yeah, so that's the that's the situation right now. Uh, there's a whole this big picture. I'm just going to summarize, the situation right now. On the one hand, the EU AI Act just came into effect. So these companies actually have to comply, or else they're going to be fined, hundreds of millions, or maybe more dollars. In a way, they have always been fined under GDPR or the Digital Services Act and so on. They sort of like pay this money like a tax, the European tax. I wouldn't say they don't care, but it's part of their accounting. But now they have more to deal with. But the funny thing is that, if I'm one of these big tech, I say, well, fine. I just have two teams of lawyers. One team, the US, I can do anything, and I go to his inauguration, so we're friends, so he's not going to regulate me. Or on the other hand, in Europe, they're facing totally different situation. I wouldn't even say about China because they're basically not operating in China anyway. And then obviously there are other countries, and each country may have their own approach. So on the intergovernment level, over the last 2, 3 years, actually there were a whole number of AI regulatory attempt to try to synchronize the laws and regulation framework in different countries. The G7, G20, and even the AI Safety Summit that was pretty much sort of spearheaded by the UK, and then all these country joined. The second one was held in Korea, and then just last year they held the third one in France, and so on. So it's like a series of government to government, like many governments trying to get together, and then a smaller group like G7 and G20. So they all have some similar or different types of these discussion about what should go into the global AI regulation. But I'm not sure whether the US will take any further active role in these discussion anymore. And then because it's regulation, this government doesn't believe in regulation. And then we have the and then we have the question is, unlike previously, the Brussels effect, will that be as prevalent? The Brussels effect means that if you think back about sometimes you get these messages saying that you're asking you when you go to a website or whatever, they ask you whether or not you want to you know use cookies or that sort of messages. It's not required by US law, but it's required by European law. So these big companies say, okay, forget it. I just do the same thing everywhere, right? And so on to comply. That's the Brussels effect, the EU effect. And now, does it matter anymore? I don't know. I mean, especially when it comes to AI. And then quickly, the DeepSeek shot. Because, well, for the last 2 weeks or week and a half, everybody is just fixated about them. What's really happening? So I think that one effect is that they show to everyone, including in Silicon Valley. I'm sure that there are other companies that are trying to train small, not necessarily small, but train models or reasoning models like they did. But maybe they didn't get the attention. Maybe they didn't get the financial support. Don't believe them when they say they did it with 6 million. It's like a wrong accounting of the cost because they bought, if not hundreds, tens of thousands of even older generation of GPUs, right? And that didn't go into the 6 million. The 6 million is just the GPU hours that they happen to claim that they use, which is like they said it was like 2.78 or something GPU hours and $2 per hour per GPU hours. And then they come up with this number like less than 6 million. Great. But they bought a whole bunch of tens of thousands of GPUs that cost them, hundreds of millions of dollars. They didn't consider that infrastructure cost to be anything. So it's just quite misleading. So all these issues about data transfer and how to yeah, questions about scaling versus innovation and optimization. I think it's true that Donald Trump said it's a wake-up call. It is a wake-up call. So right now it's just not only waking up the Americans, but waking up people everywhere because there are other countries like Japan, other countries everywhere, even global South. I see reports like people in Africa are very encouraged because they think, oh, we can do it too, right? So it's going to be a seismic shift in that sense. And then there's also the discussion argument about whether or not the export restrictions really work and so on. But some of the things that I'm really concerned about is like actually in terms of tariff, you know, Trump is saying that he's going to want to maybe impose 100% tariff on Taiwan because they're going they because of this chip thing. Really, the trade deficit with Taiwan is becoming huge. So I mean, you look at it from that angle. The U.S. response saying, "Oh, it's a huge deficit. We have to we have to tariff you." But if they do, then who's going to be paying the bill, right? Apple and Nvidia and others and so on. So Qualcomm and so on. So I don't know. And then obviously one big factor in DeepSeek success is because of the people, because these are very smart people. They're not even educated outside of China. They're just domestically educated, but they're very bright and they work like crazy. They work like 18 hours a day and then they come up with this. So what are you going to do about attracting talent? That's the question. So I think I used up all of my time. This is a recent paper that I did, which I tried to answer all these questions about even some of the questions that people have been asking, like data transfer to China and the concern censorship and so on. So you can take a look at this paper if you like. And yeah, I think I used up more than my time. Yeah.
Thank you. Big round of applause. So I want to, I don't know if is this on? Maybe. Want to give an opportunity for the audience to ask any questions related to what we've heard. Does anybody have questions?
You didn't mention anything about the alignment problem. Is it's too much in the future?
Alignment problem?
Um, when you get to super artificial intelligence, you worry about the machine not exactly being aligned with your own goals.
Well, okay. Okay.
How do you control it?
I may not be the right person to answer that question. I really would not say that I'm an AI technology expert to know what about super intelligence, what will happen, and so on. So I'm just really looking at mostly the current regulatory framework. So I don't think they have any idea what to do about that at this stage either. So that's all I can say.
Ron.
So you mentioned the digital empires. Is one of the techniques as a general thing looking more promising than the other in how we manage all this?
Well, the digital empire idea was, Professor Bradford used that particular concept of empire because it's like empire. What are empires? Empires are, traditionally, in history, you have countries building their own empire and influence the rest of the world. So he's basically coming from that perspective. These three regulatory kind of framework. And I didn't really mention, for example, the Chinese framework actually are being exported to many countries, and those countries likes it because it gives them more control for the regime and so on. So it's actually, quite popular. And then, well, they sell you the hardware, which is Huawei, and then at the same time, they sell you the philosophy, and then they sell to the government the set of regulations that they should put in place in order to, control. And it was that particular framework wasn't particular proposed for AI, but I'm just using that to sort of like if this is the way that they have been these countries, China model, the European model, and the US more like unregulated and even like big tech, you do what you want type of model. You could argue about the success, right? The US actually, objectively, all the big tech companies, all the most successful technologies come out from the US. Is it because there's this lack of restriction and regulations that enable this success? I think that is a factor. I don't necessarily think that's the only factor, right? But it is a big factor. So when it comes to data, for example, this is not even AI, pre-AI world, yeah, and because these companies, well, these other countries like China or Europe or others, they want to really regulate the kind of data flow because they feel like all the data is going to the US big tech companies and they can do whatever they want about it and make money from it, and we don't even get to tax them. And yeah, we get to use the platform like Gmail or whatever, we get to use them, but what's in it for us? And our industry cannot compete, right? So that's this factor as well. So in a sense, I think the US belief is this is not just Trump, this is traditionally. I mean, this country is like probably a lot of people, particularly you talk to the lawyers in San Francisco that serve the big tech industry. They would tell you that this is great because this is, you know, this help US innovation, it helps US domination in the tech industry. So yeah, that's the dynamic between these three empires. So which is the model that you want to go after? European, they're very, you know, fundamentally uh, for human rights, and so they all their laws are about protecting the people, and they stick with it. Some people say that that's the reason why their tech industry isn't so good, isn't so competitive, right? So China is different, right? They wall off their own country, which is a huge market by itself, to for their own companies, right? And they operate in that particular parallel universe, and it works great to an extent. At least they have a huge market and they dominate it. They kick out all your Google, Facebook from early days. So basically, these countries were not operating in their country to a large extent, any large extent in terms of platforms and so on. So yeah, so they get to do that as well. And then now they have all these developing countries that they sell Huawei over to and subsidize them, and then they created this particular, you know, universe. So that was what this empire idea was originally about. But I think what we're seeing right now possibly is how do you extrapolate this to the new AI world, to the AI regulation world?
Thank you. And thank you.
Thank you.
All right, we're just gonna take 5-10 minutes so that we can swap out the mics, and we'll have Jacob come and speak with us next on law and how the legal industry is developing with AI. All right, we're gonna keep it rolling. Next up, we have Jacob, who's representing the legal part of this discussion. Jacob is a lawyer here in San Francisco. He works with a lot of technology companies and a lot of those at the intersection of AI. So
Yeah.
with that, Jacob.
Thanks so much, David. Very nice to speak with you all. So I'm going to give a similar talk to Charles, but with a different type of focus. Charles' focus was broad, it was policy-based, it was thinking about big issues, big questions that impact lots of people. I'm going to go much more granular. You're a business owner. You're trying to build a product. Gosh, you're trying to make money. God forbid. And you want to just not get in trouble. You want to do it in a way that they're not going to come down on you, right? Because Charles, in some ways I agree with you. It's a different type of regulatory environment here than in Europe. There are still laws and they are still enforced. And so you got to think about those. And so the perspective that I'm going to try to give you is, what are those laws? And how are we thinking about those laws? And how can we respond to those laws in a way that, you know, God forbid, helps us make money, just have an okay time, build something interesting? And so we're going to walk through that. We have 19 minutes now to do it. I could go through this really quickly. Ask me questions. That's the more fun part. So we can go through this, an interesting topic. I'd like to hear what your guys' thoughts are. I talk about this stuff all the time. It's very easy for me. So some preliminary thoughts. How does the law define AI? The EU defines it one way. NIST, it's like it's a federal organization that comes up with standards. They define it. It's similar. It's not exactly the same. The National AI Initiative defines it one way. 50 different states, probably 20 different proposed AI laws in each of those states. They each define it a different way. This is mentioning the EU's approach. As Charles mentioned, the EU has one approach to regulating AI. So does Australia, China, Japan, India, UK. At the federal level, you could look at legislation. There has been quite a few proposed bills. None of them have passed. I agree with Charles. None of them will get passed. There is the executive branch where President Biden had his blueprint, his approach to how to handle AI. President Trump has a very different approach to how he handles AI. There's the judiciary, and that gets into interesting questions about the third branch of government and how they're causing the regulatory landscape of AI to change. Intellectual property is a very big space in there, and I'll spend a little bit of time talking about that, but that impacts also privacy rights and consumer rights in a very big way. Probably the most well-known AI cases right now involve copyright and the idea of fair use, which I'll talk about. Probably the largest financially, in dollar amount, probably involved class actions in terms of consumer rights and privacy. It's interesting to think about where the judiciary is on this space. How are they thinking about AI? I could talk about a case that I'm handling right now involving AI in the third branch of government. But then there's the state governments also. 50 states, maybe you've heard about a patchwork quilt or something like that, one of those metaphors. The idea is that each of them is going to pass their own laws, and they're going to pass them in different ways. I'll tell you that every state in the country has proposed a law that's trying to limit or regulate the use of deepfakes in elections. Many of those laws have passed. Nearly every state in the country has proposed a law limiting the use of deepfakes to exploit minors, and many of those have passed well. These are important laws, and it's important to follow them, but they're all a little different. And how do you follow them all in a way that, on the one hand, you're doing the right thing, because we all want to do the right things. Those are pretty reasonable laws. But on the other hand, it doesn't cost too much. It doesn't take up all your time. You're building your products rather than just doing all your work to comply. These are hard questions. And in a changing regulatory environment, it's really hard to figure that out. So I'm going to just talk about different areas of, areas of law, I think about it, but it's really areas of business where AI is intersecting, and how is the law thinking about it right now? Because that's going to give us sort of, I think, some insight into where are the challenges coming up and where are the opportunities potentially coming up. And as has been mentioned, probably the most fruitful and interesting area, at least to me maybe, and the most widely known, is intellectual property. Copyright is the idea that you have a right, a government monopoly in a tangible expression. And for interesting historical reasons, software is entitled to copyright protection, is not entitled to patent protection. So the software that is used to develop AI models is now being treated as copyrighted works. Additionally, also, and importantly, the data being used to train AI models is being treated as a copyrighted work. And that's where we get into interesting cases. I am building an AI model, and I just love every time Ron gives a speech. I just think it's beautiful and eloquent. And so I say, I want my AI tool to sound like Ron. So I take every one of his speeches that he's put into a book called Ron's Anthology, and I train my model on Ron's Anthology. And what do you know? I have a Ron copied tool, and I could just write speeches just like Ron. Now, I'm going to stop for a second. That's pretty cool. Everyone here is here because they probably think that technology is pretty impressive, right? But is that okay? And that's an open question. On the one hand, gosh, Ron wrote this book. He put money and time into the development of this book. He put money and time into the creation of those speeches. He might have spent a very long time and quite a bit of money doing that. And I've just taken them and built my own product, and now I'm going to make money off that. That does maybe seem a little unfair, at least if I don't get a license for it, right? Or I don't pay him for it. On the other hand, this is new technology. I'm not literally using Ron's words. The output of my AI tool is not in fact Ron's words. It's just something that sounds like Ron. This is a very important battle in copyright now. It's involving something called fair use. Fair use is a doctrine. It's built into the legislation. It's a doctrine that says, hey, in some cases, infringing someone's copyright is okay. It's actually okay to do it because innovation purposes, because of the way that it's being used, the amount that's being used. We think that in these circumstances, it's fine that you're copying it. That actually it's better for society, that we're not going to give you the government entitled monopoly in these circumstances. Every one of the big AI copyright cases have a huge fair use component. There is a actual infringement component. I'll tell you right now that there are challenges for the defendants in dealing with the actual infringement component. But the fair use component, very big deal. Very big question. Truly an open area of the law. I don't know what's going to happen. I'm dealing with an AI case right now. And the big thing that the judge wants to know is whether there's fair use. And we did a lot of briefing on that topic. I'm happy to talk about it more if you're interested. But that's a very big area of the law that the judges and the courts are thinking about right now. Data privacy. I'm building a tool that's going to be, it's going to make me so much money. It's going to be so awesome, guys. I'm going to collect all this data off of social media platforms, and then I'm going to sell it to someone, and it's going to be like a yellow pages in a white book that I sell for a license to companies so they can know how to contact you when they want to like sell you stuff. It's going to be so easy, right? The only problem is maybe I shouldn't be taking your address and personal information on the internet. Maybe you're saying that it was on the internet already, and why is not private anymore? Well, we have rules around how that goes, right? We have rules around the collection of data. We have rules around what you can do with the data, personal data, after it's been collected. We have rules around specific sensitive personal data, whether it's financial or health data or data about religious or sexual preferences. There are rules around this stuff. And even if the government's not in the most aggressive regulatory stance, which is often the case, there are plaintiffs' lawyers. And if you're a business, you got to worry about plaintiffs' lawyers too. I'm sometimes a plaintiff's lawyer, but there's an industry. It's a real thing where they go to enforce laws and they go after companies to do it. These consumer data privacy laws are a big one. There's a 1967 law. It's called the California Invasion of Privacy Act, CIPA. And it's a pretty cool law. It was drafted in 1967 to say, hey, you can't eavesdrop on a phone call. That's wiretapping. That's not cool, guys. So like you can actually get in a lot of trouble if you're eavesdropping on someone's phone call. So that's an invasion of privacy. And the California legislator said, we don't want to let people do that. This is new technologies. We're worried about that. And legislators across the country passed similar laws. About 3 years ago, some people were like, you know what I'm going to do? I'm going to sue a website owner, saying that the website owner who uses a third-party vendor to manage their chatbot is violating CIPA. How does that make sense? Well, it makes sense because I didn't consent to the third-party vendor listening in on my conversation. I don't know that they're part of it. But now they not only are part of it, they have all my information. They can use that information for marketing and educational purposes. I wasn't aware of that. Read a privacy policy. What are you talking about? I'd reserve to know about this beforehand. You got to be worried about that. That's a real concern. I probably deal with 30, 40 of those cases a year. There are real issues going on. It's hard to be a business owner. Cybersecurity. I think Mr. Aronchek talked about this at much more of a technical level than I could be able to talk about. But what I'll say is that if you are the victim of a cyber attack, your company's not the only victim. the individuals whose data you possess are also the victims. And there's a lot of consequences there. You gotta let them know about the attack. You have obligations under state law involving data breaches. And you might be hit with your own lawsuit for failing to protect the data adequately. When it's an AI system that was hit with that might be hit with a cyber attack, there's actually quite a few rules that are being developed in California, in Massachusetts, and at the federal level around auditing those AI systems to ensure that they are protected from cybersecurity attacks. And there's whole industries being built around ensuring that there are audits in place to and being able to complete those audits to make sure you can satisfy these regulatory requirements. Labor and employment. Ooh, labor and employment. This is actually, I would say, probably one of the top 2 or 3 largest areas of regulation around AI tools right now. Because, I mean, if anyone here has tried to apply for a job or has been on a team looking for job candidates, you probably know that with the click of a button, you can apply for a job on LinkedIn. And that's amazing. That's so cool. The barriers to entry for applying to a job are really low. A lot of companies, their reaction to that is we're going to try to automate the process. And that's cool too. Automate the process, make it easier for them to look through the applications. But regulatory bodies are setting rules on how you can do that. These are real impacting companies. So right now, the city of New York, if you want to hire someone in the city of New York and you want to use an AI tool, they call it an automated employment decision tool. If you want to use an AEDT to hire someone, you got to let them know about it. You got to do a yearly audit and you got to publish the results of the audit on your website. Doesn't sound that crazy, transparency requirements, but it's a lot of work. It's a lot of work to do, and there are laws like this getting passed across the country. All of them are kind of similar. None of them are exactly similar. California's privacy regulatory body, the CPPA, has regulations promulgated under the California law, privacy law, the CPRA, and the CCPA. And they have rules around what you can do with an automated decision-making tool, their version of an AI tool, and what types of notice and transparency requirements you must give if you're going to use it for employment purposes. This is laying out the test, the substantial assistance test. That's all technical stuff. I'm happy to talk about it if you want, but.
The AEDT is what they were formerly calling the training systems. Automated PSs.
No, it's a new term developed by the New York City regulatory body, the labor body. I think that they built it off of old ideas and concepts, but really it's an extremely broad term. Basically, it says it's any system that makes an output that could impact someone that could impact someone's decision making, and then it has specific exclusions for like calculators and Excel spreadsheets. It's a very broad term, and there's a lot of sort of technical legal issues about substantial assistance that sort of narrow it. But from a technical level, it's very almost completely all technology systems that have outputs.
It's inclusive of ATS.
Yes. Consumer protection. I think this might be near my last one, and we're getting towards 20 minutes. Obviously a very broad term, but this is a big area of concern for government regulators. In fact, it's kind of the whole ball game in some level. Governments are there theoretically to serve the public. Oftentimes the people in the public are consumers, right? You wear a lot of hats. You're a mom or you're a dad or you're a student, but also you're a consumer. You buy stuff, right? That's reasonable. And so you should be entitled to consumer protections as a consumer. That's pretty reasonable too. And there's a lot of laws around protecting consumers. This is just an example of a handful that we just look through when we do our regular research at my law firm. We just make sure that we're monitoring the development of AI legislation, right? Some of it gets passed, some of it doesn't, but there's a ton in this area. Very big concerns around discrimination in purchasing decisions, in lending choices. That's a really big one. Discrimination in hiring, mentioned that before.
This lending you mentioned employment. One of the things I've come to a little bit is So a bank's gonna say, hey, we're all securities making.
Yeah.
We want to take all the data we have for the successful loans that have done, and we want to use that to train our model and
Yep.
automate.
Definitely, definitely, totally.
If you secretly, unknowingly, then compete against this. Stop.
Heck yeah.
Now are training.
Yeah.
Systems to be.
Super messed, right? Jeez, yeah.
Same thing with weather data. You got people in your, there's a whole.
Yeah.
Ways that stuff can get, bad behavior can get automated and institutionalized.
Totally,
to a
dude.
Permanent level, which is really kind of scary.
Yeah. It's the state of New York, mid-January proposed a law. The New York Assembly proposed a law. Hey, we're just like you're saying, worried about discrimination in lending decisions by banks. So we're gonna think about some regulations around this. Like, and how do you regulate? I mean, Charles talked about this very effectively. Sometimes it's transparency rules. Sometimes it's prohibitions. Sometimes it's explainability and disclosure information. Sometimes it's a private right of action and let the private parties fight it out and get all mad about it, right? A lot of ways you can do it. There's a lot of interesting research on which are the better ways or worse ways, but it's happening. It's really happening. And so I guess what I'll leave you with now that we're at 18 and a half minutes and I can have time for two questions is like, how are you going to move forward in this regulatory environment? Like, what should you do in this regulatory environment?
Start with some, antacid.
Yeah, sure. Yeah.
Start there.
Yeah, no, I get it, man. I get it. It's a lot and it's like super diverse and it's kind of confusing. But let me just propose this thing for you. Like the goal here, not only it's always accomplished, but the goal is to like have reasonable laws that help people build stuff in a way that's fair, have products that work but don't hurt others, right? That's the goal. Doesn't always happen, but we want it that way. So if you take that framework and that's how you're thinking about it moving forward, and yeah, if it gets complicated, talk to a lawyer, call me, whatever. But if you take that framework and that's how you're approaching it, there's a good chance you're going to be all right. And so I hope you guys go forward and prosper and build some cool stuff.
Thank you. Are there any more questions for Jacob?
And what's your opinion about Ron Obama leading the state? Are you going in the right direction?
I don't. Yeah. So I know some stuff about what Ron Bond is doing, specifically about AI stuff. Is that what you mean? I'm gonna admit that I actually don't know about any of Ron Bonta's AI work. I do know about Scott Wiener's AI work in that frontier legislation that Charles mentioned. I mean, that's I what I'll say is that I think the reason that Governor Newsom vetoed the frontier legislation last year was that it was very, very broad. And I think that it's kind of reasonable for him to recognize that there was a serious headwinds in the legislature in favor of a consumer-facing law like that was very broad. And even Scott Wiener, who's not here today, so he can't respond, has mentioned on the record that it was a very broad law and that he's intending to work with industry groups to narrow it. And he's going to propose something this year that's a narrow version of the frontier legislation. I think having something like that's a pretty good idea, but I'll admit I don't know what Bonta's doing about AI. So yeah.
Liability.
Yeah, well, it's a great question. I mean, ultimately, a human being's got to be liable, right? A human like we can't be having computers be liable. That at least right now, that is not a concept cognizable under the law. It's just not. So what does that mean? Like, the buck's got to stop with the company, right? And and lawyers will fight over indemnity and blah 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 and contracts and where does it actually land. But ultimately, it's got to be the person that developed and is making money off of it, right? That's how it works, right?
All right, Jacob, that was awesome. Thank you very much. I should also mention, especially now that David's here as well, Jacob has partnered with David and I to help put on these events. Kudos. And Boris Kirchhoff, who is not unfortunate, he has a real job, unlike the rest of us. He had to travel to a different state, could not make it here tonight, but thanks to Boris right now. But thank you, Jacob. That was great. So next up is David Issa, who's been our MC. He was our MC at our last quarterly event at Global Encryption Day. This take is actually more closer to what David is known for. He is a CTO at a healthcare tech company. And this is his neck of the woods. Definitely qualified to talk about the impact of AI in this arena, just as Jacob was for legal. So just want to say thank you, David, for doing this. You're doing double duty, and
Thank you. I am very happy that MC is not my full-time job because I don't know that I do that well enough. Good evening, everyone. As Ron said, I'm currently the CTO for a digital healthcare startup. I have been a strategic advisor and consultant to many digital healthcare companies over the years, specifically in the early stages, and then for those in later stages undergoing digital transformations. A lot of what we've seen in digital healthcare, in my opinion, could be described over the years as mediocre at best. I think it's failed to deliver on a lot of the lofty promises, that they aspired to set out for. But AI represents a new frontier, I think, in that development, and a more exciting frontier that could possibly drive more change. But there are some warning signs and warning flags. What I want to talk about today is a little bit of what's going on in the industry, and understanding that I'm coming at it from a little bit of a perspective where there's two primary personas that lead healthcare companies outside of digital health: businessmen and women, and doctors. And they'd often have limited views of or understandings of what technology can do and how they can be applied. So I often am the one that gets the question of, hey, I was at the country club and I was talking, to my friend who went to AI Day, and he said Kubeflow was the thing. We should do Kubeflow. And I'm the one that has to say, okay, let's understand the context. Why? Why are we trying to do this? As we all know, we're entering a defining era, I think, in healthcare. AI is no longer, and I think we need to think about it a little bit more than just an automation tool. Though that's what many of the companies are coming and thinking of it as, right? The ability to automate some of the human capital that I have within my workforce today. And really what we're talking about is it's the beginning of the ability for a machine to anticipate and predict human intention before oftentimes we go for it. A little minority reportish, I know, but with enough context and data, AI can certainly foresee our actions and begin to prompt and guide and drive outcomes as we see fit. So we have to ask ourselves, how are we going to ultimately begin to leverage this when it comes to healthcare? Because it can do tremendous good in that context. And we're already seeing its application today, even if it sounds futuristic in finance, marketing, especially, and then in some instances in healthcare that I'll start to go over now. One of those instances, right, is the Children's Hospital of Colorado. They leveraged AI's predictive influence to help prevent suicide in children, and had tremendous results. They end up being able to flag around 85% of at-risk youth before they show clear signs of disease. But how was this rolled out, right? This was a very small subset that was done. Doctors who collected this data very specifically designed a survey that was going to be done for this intention, and then said, hey, every time the children come to the hospital to, for an annual checkup, it could be for any checkup that they come in for, we're just going to collect this mental health survey data, regardless of why they're there. And they were able to show these tremendous results. That's incredible, right? We're now giving a human, in some ways, a superpower to intervene earlier, more effectively, and save lives ultimately. And that's what preventive interaction can look like in action. I don't think it's, I think it's a small subset use case of really the power of what AI could do, not the true impact that it could probably deliver at even greater scale. The reality, though, is AI is a mirror of human values, and it's doesn't create intention. And this is where I think a lot of confusion is starting to happen. It mirrors it. So it's going to learn from the training data that we've delivered it, right, from our past actions and the data that it's given, and ultimately accelerate our existing systems, the systems that we have currently in place, to achieve whatever outcome or goal that we are driving it towards. So AI alone is not going to fix healthcare. It will automate and amplify whatever mission ultimately we give it. And if we don't start to rethink healthcare's core incentives, and I would say that this is true for any industry or any business that's out there, we're simply going to accelerate the existing and underlying efficiencies, inefficiencies, inequalities, and misaligned priorities. So it brings us to sort of a fundamental question that I think many are trying to drive, especially in this country, more so than in some other institutions, which is healthcare a business, or ultimately is it a mission to heal? Because it's only going to be as ethical and effective as the system it serves. So where it stands today, and I think we're all aware of how it can go wrong, right? It went dangerously wrong in this instance when aligned with the wrong incentives. And the part that I want to bring up around what happened in United Healthcare's process is, the AI didn't do wrong, right? The AI was designed to optimize insurance payouts, right? Reject valid medical claims, according to the lawsuit, at unprecedented rates, meaning it took the legacy data that it was given, right? And it was just able to do it a lot quicker than any human could do in that case. And we saw, a tragic fallout from that, and then obviously the ramifications of that. But this wasn't an AI technology failure. This was a systemic failure. It was an intentional outcome based on AI prioritizing financial gains over patient care. Alternatively, we've seen AI deployed in different ways, where at the Mayo Clinic, they leveraged it to reduce hospital readmissions by 40%, identifying high-risk patients before complications occur. These were cardiac rehabilitation patients. They were given a smartphone app along with some wearables that it was being used. And then by intervening before a dangerous event happened, they were able to take the emergency room visits and hospital readmissions, down. Now, that does not mean that Mayo Clinic is better than United Healthcare. I don't want to paint that perception. Part of what we're talking about is still an economic incentive that's driving, why they're using AI in these results. The most expensive piece of real estate within the hospital ecosystem is that surgical OR room. And the way that the economics work is they are driven to keep that surgical OR 100% utilized, or as nearly to 100% as they can use, because anytime it's not being used, it's costing them money. So there's a dark underlying belly that's existing at that, behind these scenes, but we can see where AI can be used in that context to really accelerate the good. Same technology, radically different results with the mission behind it change. when AI is done well, and this is the part I think for much of society, not those necessarily in this room, um, it doesn't necessarily replace care. It can enhance it, but it does it with what I call an invisible hand, guiding, whether it be patients and or providers, ultimately towards better decisions and better outcomes. So fictional story, you have AI augmented care journeys. And when someone says that, what does that look like? Right? You have an individual potentially with type 2 diabetes. And with AI, what we can do is we can do real-time monitoring. We can do predictive interventions before blood sugar spikes happen, subtly nudge people in the right directions, give them predictive alerts before the complications arise, and ultimately start to bring the costs that are in healthcare dramatically down. And why this works is because it's not an app that I have to monitor checklist. It's not blunt force the way that digital health was historically. It's subtle, it's psychological, it's personal. It's taking in the individual's context, the understanding of all the data that's delivered to them that you theoretically would have trained it on, and it's using that data to subtly influence and guide you towards an intended outcome ultimately. Where we see it in healthcare kind of working today, I think with greater degree, is in what I'm calling just human-led AI-powered care, right? And it's what I think is the necessary balance at best with what we're delivering. And a lot of the healthcare executives are sort of aligning around this, mostly from a liability concern, right? Ultimately, but it has potential, right? Doctors are expensive, and there are less doctors than patients, for sure. So there is the ability for AI to tremendously amplify, the skill and the capabilities of those individuals, as we've seen in the NHS case study. They did a pilot, and once again, these are pilots. These are not what I would consider full, what you would call production delivery, where they did a pilot with a little bit over 700,000 women across 30 clinics, and went in and trained the AI on historical breast screening, mammogram results, and then use that data to predict, and try to detect early patients that may have a higher risk of getting breast cancer. This was tremendously successful. I don't think they reported out the specific rate that they resulted in it, but the key factor here was that the doctors were able to analyze over 700,000 women, a number and volume that they would not have hit before, allowing them in some ways to provide more personal care in front of them than they have ever before. Another company called PipCare, they are thinking about it and achieving results with the human touch. The notion that people respond to other humans better than they will others. And in this context, they're thinking about how AI can empower those health coaches, similar to those radiologists that I talked about in the NHK example, to deliver higher quality, more personalized care at scale. And in this world, once again, back in the surgical OR example, they're reducing complications by 35% and the length of stays within those institutions by 2 days. This balance, right, with AI-powered, human-led, is a current sweet spot where we're seeing great outcomes in the industry. But I'm going to be honest, I think it's reductive. And I don't think it should be the final step. I say that because in some ways, it's a stopgap that's holding us back from really what the true full potential of AI could be in the right hands and the outcomes that we can achieve if, you know, and I believe we can overcome it, but how is going to be critical. And the root issue here is incentives shape outcomes. That's the bottom line. Even if they're human-led. We saw this with Theranos, right? Even humans, when operating under just the wrong incentives, can drive catastrophic failures. I don't think you need AI to do that. It is a failure of the systems and the incentive structures that we've currently set up. And that is, you know, this is the perfect example, right? They had, despite having a lot of skilled professionals on staff, their incentives ultimately led to poor decisions that endangered thousands for selfish reasons that we could probably understand. But I'm using it more as proof that the incentives are what dictate behavior, whether it is human or machine, in that context. So what I'm trying to do is get individuals to begin to understand now more than ever, right? Every leader in healthcare and ultimately beyond must define what I'm calling their immutable mission, that unchanging mission that can be the North Star to drive the vision and ultimately the outcomes that something like AI can be delivered, so that we achieve the right results from these implementations. Because without a higher purpose, right, human behavior will be co-opted by AI, not for healing, but for profit maximization, efficiency, or whatever goal we unconsciously ultimately embed into it. It's like if we feed it a whole bunch of historical stock data, it'll repeat what that stock did historically, and it'll become a self-fulfilling prophecy. So the challenge that I'm delivering, right, is I think every institution needs to really redefine what its purpose is and rediscover what that is, and then recognize that ethical responsibility towards it, and then ultimately ensure that AI is accelerating the good, in this case with healthcare, towards healing and not the harm. So establish a mutable mission, give AI a higher purpose, and then ultimately, you know, bring healthcare over to what I think its true goal is, which is a mission to heal. Thank you.
All right. Thank you, David. That was great. Questions?
Good question. David, what are your thoughts on Stargate that team comes to life that's in the fighting?
Stargate,
So
correct me. I know it. I'm
Trump,
like
the
blanking.
500 billion AI investment from the government.
My thoughts on it. I mean, you know, in general, I'm gonna be the person that's gonna hold the leaders ultimately accountable. So investments, I think, are great, right? They can accelerate R&D and positive force. Ultimately, I would go back to what is the mission that we're driving for. And I think what we've found today in many of the corporations that are longstanding and existing, the missions that they've set out aren't enough, in my opinion. And while I applaud the funding, I think there is a giant step back that needs to be had with the direction that we're ultimately heading in. And I would say this is true even in the consumer space. You know, there's a common theme around, you know, optimization where quality seems to go down, but prices seem to stay the same. And, you know, year over year, right, that trend is there. And I think we have to ask ourselves, you know, are we driving that to a point of a world where the businesses themselves are killing their own consumer base? And there's declining populations, you know, in more countries, you know, around the world. So the question is going to force us to think about, you know, are we trying to turn a new customer over every quarter, or are we going to try to amplify the lifetime value of a customer over time? So I don't know that I have a direct opinion on that particular piece of legislation, but I have a strong opinion about the why behind a lot of the startups and the business that exist today.
I had a second question as well.
Yeah.
A slide. So, the opportunity where AI is kind of delivering itself with a women's clinic where it can actually potentially kind of give a fair warning on from a previous scan or mammogram. Do you think that with the advancing and AI agents that are currently being developed as we speak, as that continues to develop into 2025 and 2029, do you see an opportunity for AI to integrate itself with some of the larger healthcare facilities, UCSF, Stanford on the 75 Lake Woods, where they also can, just as you mentioned, provide the best quality they can and keep that trained patient there, but also provide them fair notice?
Be sure to rephrase it.
Yeah,
Sorry, in a smaller term, I would say, do you see a potential partnership, just with your experience in your ecosystem, a larger healthcare facility?
the question is, will larger healthcare facilities, begin to leverage AI towards these positive outcomes? So there's an interesting fight brewing within healthcare right now as to who owns the data. And what's interesting about it is there's one large monopoly within healthcare on the EMR side that owns, I want to call it 80% of the market, maybe more, at least the big ones, and that's a company called Electronic Medical Record. So this is like sorry, thank you. This is a very large like ERP system is probably the best way to think about it. And everything is logged within the EMR. A company called Epic it monopolizes the market on there. And ironically, Epic's contracts that are signed, that you sign with them, says that they own the data. And the hospitals believe they own the data. And then there's a strong case with HIPAA that no, we, the people, own our personal healthcare data. I do think, companies like Epic are starting to kind of implement that and we will see positive outcomes in it. And I think those outcomes are going to be focused around driving us to not necessarily be healthier, but need to use the healthcare resources less. So I'm not going to necessarily, if I can find ways to just keep you at home and sick, it's a more profitable outcome for me as a company than for me to kind of have you not engaged at all with the system. Because if you're not consuming services, you're not paying. That's the unfortunate thing.
For our last speaker of tonight, we'll have a few minutes to wrap up at the end, but last presentation for tonight, we have Allison from Neo4j, whose comrade Naya unfortunately had a family thing to deal with and could not join us tonight. But
You'll be sad that you missed out on Naya because she's amazing. She's also local to San Fran, so if you ever have the opportunity to see her speak, you should definitely check it out.
Yeah, so maybe right before we start into our next and final session on the environment is to just mention once again, Neo4j, Yolanda here in the back, so please talk to her as well, help with the food and is just a great supporter of, quite frankly, all the computing and meetups and everything that goes around town. Neo4j does a great job. It's Graph Database. If you don't know what that is, I won't mess it up for you, but it's really cool tech. Allison will maybe talk a little bit more about, but thank you again to Neo4j for their sponsorship. We really appreciate it. Allison, thank you for being here. We're looking forward to the environment.
First of all, I want to thank everyone for being here all day. Like,
Yeah.
The amount of attention and just the interesting conversations that I've had has been such a joy. I'm actually from the East Coast. And the other thing about the talks this evening, I felt like it was a walk through my history with AI. I started out in healthcare at a hospital working with Epic data, and then recently was working with advocacy for copyright for authors. So it's just been so many different topics this evening. I was like, oh, there's my career in one evening. But what I'm going to talk to you a little bit about today, AI and sustainability, right? I'm from Vermont, so hence the sustainability, like the Green Mountains, but have been working in AI for a really long time. And so has anybody ever seen, I don't know if anybody's ever heard this story. I saw it in Charlie Wilson's War, that movie, but about the boy who gets a pony and he says, oh, I got a pony for my birthday. Isn't that great? And they say, we'll see. And then the child falls off the pony and breaks his leg, and everybody says, "Oh, that's terrible." And they say, "Well, we'll see." And then there's a war, and all the boys have to go off to war, but he doesn't because he's injured, and it's we'll see. And one of the reason why I'm telling this story is that the same thing is happening when we think about AI, right? All of a sudden, AI is in the hands of everyone. Isn't that great? We'll see, right? We know, I mean, man, everything has changed. Everything's changing so fast, even in the last week, with DeepSeek. What my talk looked like a couple of weeks ago versus what it looks like now is clearly changing. But some of the things that are really interesting, like when the executive orders came out with the new administration, they put out one about AI and like taking back what had been the original viewpoint. But also, did you know that there was an energy emergency executive order? Yeah, right? Yeah, see, not everybody knows this, but it was really interesting to me is that on the one hand, we're saying, no, we want to keep all of the compute chips here, but we really need to make sure that we're not overusing too much energy. Now, the reasoning behind each of those may not be what we're talking about here, but the idea is we are in this really interesting moment where we've got all of this potential and what can come, and all of this massive compute that we've been using to do all these really incredible things. But we also are really taxing the resources that we have. And it's not even just from, there's the obvious like climate impact, but also just the national infrastructure of the energy grid, right? So we know that we've got these rising energy consumption, and we've got these environmental consequences, and these two things are in conflict, right? And that's really what I want to talk about tonight is what that conversation looks like. What are some of the successes that people have had, and what are some ways that we can start to think about it and bring it into our daily thought process of what is my contribution, what is my company's contribution, what are we doing here, and what's possible. So some of the statistics around the energy demands, global power consumption, AI was set to consume about 8% of all data center power in 2024. That number is continuing to go up. Obviously, everything's changing with how quickly people can actually build training, but even inference is still going to have a really heavy piece to it. Also, as we get to these places where, I mean, people have talked about so many things today. We've talked about fine-tuning models. We've talked about, being able to sort of like hack your way and reverse engineer different models. This projected growth is only getting bigger, right? We're seeing that it's by 2030, data center power demand is expected to increase to 606 terawatt hours, right? That's 11% of total US power demand. That's a massive amount of energy, right? And so when we start thinking about what is that impact on the planet? What is that impact on the country? What does that mean to the prices of the AI and the business and all these different elements? We can see that it really is getting significantly larger by the day. again, AI specific model consumption, when we talk about GPT-3, and again, with DeepSeek, like everything's changing, it was 120 megawatt hours just for training. And then obviously, the environmental impact, which is really what we're talking about, that the carbon footprint of AI models is substantial. Training a single deep learning model can emit CO2 equivalent to the lifetime emission of 5 cars. Right? This is not an insignificant impact that we're having on the planet and on energy stores. And, as someone who's been building models for over 10 years, we don't even think about it. We just run it, right? And especially with cloud compute, like, oh, I'm just going to spin up what I need and then spin it back down. Or, you're using like a data robot, or where it's like, oh, like run 12, 1,500 different features, run all these things and give me the best possible outcome, right? We are, without even thinking, asking for massive amounts of compute on the regular. And I don't think that how many people does that cross your mind when you're actually working on the daily? All right, we have one. Yeah.
I worked with energy.
Oh, okay. See, there you go. Like, you've got the inside scoop, but we don't even think about it because it's just a line of code or clicking a button. It's not the same as when you're in your house and you turn off the light, or you don't keep your engine running, or, you decide that you're going to like walk to the store instead of drive. Like our kids have ride your bike to school day, right? All these different times where the physicality of the energy consumption is much more obvious. Turn off your air conditioner, don't heat the pool, right? But what we're doing in our daily life with our work is we use energy without even really thinking about what that looks like. And so what I want to walk through a little bit today is what are some of the opportunities that come from this compute? Obviously, we get efficiency improvements in AI, we get optimization, we get automation, right? AI can help us reduce labor costs and improve resource management, and all that sounds great, right? Well, we'll see. There's a concept called Jevons paradox, and it's been around since the 1800s, and it was ideally around coal. But what it says is that as technology makes resource use more efficient, it leads to an increase in demand and often outpacing the efficiency gain. What it leads me to is this, we're talking about DeepSeek, and we're talking about, oh, like it can be so much cheaper to train, it can be so much, easier to infer. Well, is it now possible, like when we said, we're putting AI in the hands of everyone, does that efficiency lead to so much more use that we're not even getting the efficiency in the end because we end up using more of it? I mean, we think about the compute on our phones, and we think about all that's at the edge, which is a whole other thing. But, what's happening with retraining our models? We were talking earlier about, the responsibility of having ethical models, right? Well, life changes, and everybody knows eventually your model's going to degrade. So we have to retrain, or we have to fine tune, or all the different ways that we have this compute. And so even if we're trying to make these strides, you have to keep in mind, like, what is it net in the end, right? Is it necessarily making us better off? We still have to try, but we'll see. So what are some of the things that people are doing already to help combat that? And there's lots of things that are going on. DeepMind research, they did research on optimizing energy in AI models through using different algorithms and cooling systems. I also have like links to everything that we'll get to everybody if you have questions on this. Microsoft in Iowa actually did some really interesting water cooling technologies. And it's one of the most efficient, it was like the first really highly efficient data center. And so it shows how you can have these sustainable infrastructures and how it can lower operational costs. Right. I was talking with my brother today. My brother was a test pilot in the Navy and is an aeronautical engineer. And he was talking about, it was really interesting how they had these chips, and they were originally designed for submarines, but they needed to use them in aircraft. So in order to use the chip as it was, they had to design a cooling system so that when they were on aircraft carriers and it was really humid, it would keep the chip cool. But then when the planes went up into altitude, they had to have a heating system. And so like all the heating and the cooling around just making sure that a chip is functional on an airplane. Right. So it's not even necessarily the compute, but it's all the different pieces around it. Like, what is the water requirements in different areas where we have these data centers? If you're responsible for, if you're a CIO or a CDO in your company and you're using AWS, I have another brother who works for AWS, and he always tells people, he's like, listen, machines are going to go down, right? It's just going to happen. What kind of redundancy do you have? And so we have to have these redundancies to make sure that we keep our critical systems running, but that's going to have an impact on compute as well. And none of this to say that, oh, well, stop backing up your systems. I'm certainly not saying that at all. But what I want to bring to your attention is all the different ways and all the different conversations we have in these technical meetings have energy impacts, and they have sustainability impact. And I just want to like bring it to your attention, like, is this something that we can or should be thinking about? Obviously, DeepSeek has done some really interesting things, right? They're another company that has said, okay, now their motivations may have not been from a sustainability perspective. They were coming from a chip constraint, but that, what do they say? Necessity is the mother of invention. And so, what is possible that maybe we haven't considered? So when we think about it, if you're an AI specialist, I don't know, does anybody in here actually build models on the daily? Yes, we have some. The next couple are really focused just on like the actual AI technologies and things you can do when you're building your AI models. One of the things that you can do is pruning, and so it's a way of taking out unimportant weights or neurons in your deep learning models to make the model remain efficient but not lose accuracy. So it reduces the computational burden. An example of that is Google's EfficientNet. It's a couple years ago, but it still sets a good precedent. Obviously, what DeepSeek is doing, the way that they've optimized their computation is another really good one. Oh yeah, quantization. Quantization just looks at, and this is something that applies to software developers too, but what is the actual data type that you're using? Do you have a really long float where an integer could suffice, right? Are there other ways that we can make these small changes that can have larger impacts? So that's another interesting thing. TensorFlow Lite was really more for like making things at the edge. And that's the other thing too, like who is here? Oh, he left already. Thinking about what are the ways that we're optimizing at the edge, and are there things that we're doing at the edge that we could then bring back where we don't think we're resource constrained, but we can take those lessons back and use them in, cloud environments or in central environments and not just at the edge. Model distillation, everybody's talking about it. It's the hot topic. Training a smaller, simpler student model on something that, came before, like all roads lead to DeepSeek. But really just looking at different ways, like how, if we are doing the fine tuning or if we are building something, could we possibly take a distillation approach and have as good an outcome and not necessarily like have that heavy compute, right? And again, like distilling GPT-3 for small devices is one of the things that they did. Okay. And so that's sort of like on the actual AI and the building side. But, as software developers, it's a very sensitive button. One of the things that you can look at doing is you can look at optimized methodologies. So for example, if you're, I will say, yes, I work for Neo4j, but I'm not saying it for this reason, but it's actually really true. If you run graph queries on data that we've seen in SQL queries, especially if you have a lot of sparse matrices, much more efficient, just sidebar, just saying. But even in just the way that we're doing, so like right now, I feel like 24 was the year of GraphRag. So anybody here working on retrieval augmented generation applications? A little bit. Yeah, I mean, GraphRag is a really great way to do it. Like our benchmarks, it's a 30% decrease in computation that's required when you're running GraphRag instead of a vector database retrieval augmented generation. You know, your AI needs knowledge and it needs grounding and it needs facts. So just looking at, are there different databases or are there different methodologies that are going to be more efficient? You know, it's not just about like, you know, yes, it makes the application more efficient, but even if, you know, from the user perspective, whatever that difference is, like doesn't seem important, we can recognize that when we look at it systemically and we look at what that larger carbon footprint is, it can actually be very impactful, especially the more, and if you're lucky, all of us work for companies where we've got millions of users and everybody's doing using what we've built. So small differences have really large impacts at scale, right? So looking into your optimized methodologies. The other thing is if you're doing training, if you're running big jobs at different data centers, can you be doing them at off-peak hours? Right? Is there something that you can do when there's less, you know, less pull or ways you can do it? One of the things I love about AWS is they actually have really smart storage. So you can send things into deep storage and it uses AI to actually manage some of that. So look at your providers and look at the people that you're working with. What are there different options that you can use across your offerings that you can say, oh, like this actually will be more helpful because there's less that's live at any given moment. There's many, many more ways. You know, one of the things that somebody talked about was, you know, what is the energy around actually spinning up a cluster and then shutting it down? Or does it make more sense to like, you know, balance across them? So there's some really interesting things there. That's a little bit outside my particular realm, but it was something when I was talking to folks about it, came up and was really interesting as well. The other thing you can do is, and this is super fascinating. I don't know if, and is anybody here aware of Code Carbon? It's this really lightweight Python library, and it will actually tell you what the CO2 carbon emission is based on your code. So that's just another really fascinating and interesting way that you can take a look at what you're coding. One of the things about using like a Copilot or, you know, different ways of like having your, somebody was saying earlier that their child had just graduated or someone they knew had just graduated from college and was responsible not for actually coding but for reviewing other people's code. And you know, I was,
The code made by machine.
yes, was that you? It was somebody at our table. It was, oh yes, it was Steve, you know, yeah, with the silent E. Was saying this, yes, yeah, I was listening to our phonics conversation, so many interesting conversations today. But it's this idea of like, when it's being generated, is it optimized for those sorts of things? Can we make that part of the prompt? Right? Is it as simple as adding it to the prompt when you're sending something to Copilot or saying, hey, take a look through this code and see if there's a way that we can, you know, reduce the carbon footprint of this code, right? So there's lots and lots of little things that we can do as individuals. The last little piece that I want to talk about is, you know, as tech leaders, what's possible? How do we actually bring the conversation to our teams, right? Do we set energy efficiency metrics, right? Do we actually look at what is the carbon footprint of our company from a computational perspective? Cross-department collaboration, really figuring out that this idea of sustainability, it's not just the developers, but it's everybody. Like talking to bringing it as a conversation to your product managers, bringing it to your analysts, figuring out, you know, how do each of us contribute? What are ways that any of us can think through what we're doing? You know, for me, responsible AI is it's about the ethics and the bias and the facial recognition and all of that, but also really considering this climate piece on a much more regular basis, I think is only going to really help what we want to leave as markers behind us, right? You know, we are in this AI age, and we are literally creating the future every single day. We are creating what is reality every day. You know, our entire lives are algorithmically curated. You know, what is our news comes to us through an algorithm. What shows get recommended is an algorithm. Whether or not we get a loan, which loans are provided, like our entire existence and even our reality of what is a fact is algorithmically curated. All of that has computational cost. So we are, as consumers, as well as designers and builders, we are so deeply enmeshed in this conversation of what are we creating and what is the impact of what we're creating. And it's not just from the bias and the AI point of view, but it's also from this climate point of view. Yeah, the last piece, like look into whether, you know, different folks are using more renewable energies and different cooling techniques and things like that on your cloud providers. So the question that I ask and that I leave you with is, what will you do? You know, there's something that I've said tonight that you're like, oh, yeah, I could contemplate that, or oh, I could throw that in there. There's something really easy, right? Is there anyone here who, yes? Hmm. Yeah.
Relates in some way to what we're doing. So, Bourget asked, do you have any guidance or case studies or?
I mean, I can tell you who my favorite AI B Corp is. My favorite AI B Corp is a company called System. And they, you should look it up. Adam Bly, he's like been my data science hero for over a decade. Like he's genius. And really what they're doing is they're doing the connectivity of scientific research. And they're actually doing really interesting things with climate research and making that available. It leverages a knowledge graph. Like you should definitely check it out. It's one of the most interesting things I think that's been built in the last few years. But, you know, some of it is, so is the question about if I want to be an entrepreneur in a B Corp, like who are some good partners for me? Or what are some good methodologies?
If there's a playbook for builders that take into consideration the B Corp or the SD.
What is a B Corp?
A B Corp is a corporation that is, it's not a nonprofit, but it's for public benefit. So it's a company that has like a positive mission. So I think like Seventh Generation is a B Corp. Ben & Jerry's from Vermont. Yes, my hometown. I went to the original Ben & Jerry's in Burlington when I was a kid. Yes, I'm that old. Yeah, Patagonia, there's a number of them, REI, right? There's a number of them. So I don't know if there's necessarily, like, it's a really good point. Like, is there an AI playbook and some guidance for B Corps to be more responsible in AI? I will say the AI and sustainability conversation, it doesn't happen a lot. Right. I mean, I haven't actually seen it before where people really talk about it a lot, at least not in these circles. So it's definitely something that, you know, Neo4j is really supportive of. You know, they really wanted, it was really important to the company. You know, we have good Swedish background to make sure that we bring this to the fore. And it is something that comes into play in their product development. And what they're building and how that works. So, I mean, you can definitely talk to your partners, talk to different people, but really like bring it to conversations, bring it to like anyone that you're talking to and investors that you're talking to, because the more we talk about it, the more it goes, right? So what will you do? We'll see.
Yeah.
Any other questions?
I have one.
Yeah, sure.
So this is somewhat of just a personal observation and a question.
Yeah.
So I've been CTO of a couple of energy companies.
Yeah.
And the only thing that seems to get people moving is their bill. Right? We could, again, this is my retail space experience in it. And so when the bill is low, no one says a word about energy.
Right.
When it's high, it ain't about how much energy they use. It's about why is my bill so high.
Exactly.
Right?
Yeah.
And so I find and that's just the consumption retail, you know, just to my house, you know, that.
Yeah.
Kind of thing, right? Then there's people in the industry and people working in energy, and very few people, in my observation, actually have any innate ability to judge energy like consumption. Like, when you say megawatt, is that a lot?
Yeah,
You
yeah,
know, like your house uses 1 megawatt a year,
yeah,
but is that if that's normal? Then is that a lot? Is it a little? I don't know. Like
yeah, that's a good point.
unless you're like an expert in these things, like you have no tactile
Right.
feel other than your bank account going.
Yeah.
So, you know, AI or not, like,
Yeah.
do you think there's some way to make people care? I mean, people say they care, but like, short of money, like, how can you train them to know? Like, because if you just spit out numbers like the tool here for
Better coding practices.
Yeah.
it doesn't mean anything to me. It's just a number. Like, unless you give me all the background and all the comparative analysis, like,
Yeah, I mean, listen, it's like any sort of initiative, right? I mean, to your point, you know, if you need to build something with less money, you're going to find a way to do it, right? Like, there are folks who look at their AWS costs and they're like, oh no, we need to roll that back, or we need to do something different, right? It's like with DeepSeek, necessity is the mother of invention. So in that regard, if money is no object and it doesn't matter, then that's not going to be a motivator. But why we talk about like, what is the culture of sustainability? Like I said, you know, when we're just clicking like rerun, retry, redo, like another image from Dolly, like we're not thinking about compute. And I think when we look at the way the green initiatives have changed over the last, you know, 20 years, it's because it became part of the conversation that now people think about it, right? So some of it is we as individuals need to take accountability for bringing it up. Like if you're running a conference, have somebody come in and talk about it. If you're doing a day on AI, talk about it. You're running a team, talk about it. Do a hackathon day where you're just like, hey, like every year on Earth Day, you do an internal company hackathon where you're like, let's see how we can lower our carbon footprint, right? Like there's so many different ways, like it's like any initiative, right? Like you've got to find ways to gamify it, and you've got to be willing to be someone who's going to stand up and say, hey, this is an interesting conversation. Let's talk about it. Yes.
That little widget that you said, that's just a little Python package that says, here's the carbon footprint, whatever it is you're doing.
Yeah.
What a great way to, like you said, gamify.
Yeah.
Like, what a great way, like, you're not tracking it,
Yes.
right?
Yes.
You don't measure Canada for you.
Yeah.
Carnegie
Yeah.
capability maturity model. You can't measure it. You're never gonna, you don't even know.
If you can, yeah, you can't manage it if you're not looking at it and measuring it. Yeah. Set your metrics. Yeah.
Economists keep telling us carbon tax,
Yeah.
and that fits with people pay attention to what costs them.
Exactly.
I was just gonna say that another way to put it is culture of constraints.
Mm,
Instead of like sustainability is a constraint, right? So
Yeah.
think about a constraints. So you're in sustainability, you're constrained by, you know, energy footprint, carbon emissions, all sorts of things. But there are things, you know, number of GPUs,
Yeah.
power of the GPUs instead of like H200 or 100, use H800s.
Yeah. Yeah. Use like the size of the machine that you need. You know, I have a really good friend who was the head of sustainable economics at the UN for a long time. And when my kids were little, I said to her, I was like, okay, what's the greenest way to go? Disposables, cloth, like flushables, what do I do? And she's like, well, it depends. And I was like, well, what do you mean? She's like, it depends on where you are. Because if you're in Africa and it takes you, like, you have to walk to go get water, cloth diapers are not going to help you, right? Like, if you're somewhere where you've got plenty of water, but, you know, you've got a sensitive water system and you don't want bleach going into whatever the local system is, that's going to be different. And so I bring this up because what's going to be the right sustainability measure for you to take is going to be different. This isn't a one size fits all. So think about what your constraints are and what still works for you. One more?
Oh, yeah.
Yeah, go ahead.
I'm here just for camera, not.
Oh, okay. Yeah. No worries. I got like the big cane. And
No, yeah, I know. I
the
felt that
orchestra's
way.
gonna start
I
playing.
felt that way. I
It's
was
been
like,
a long day. I wouldn't be
we could stay
surprised.
here all night.
Sorry, go ahead. Yeah.
Like, for example, you know, the pumping station at the base of the grapevine, everyone knows that. Anyone. Like, anyway, the push of the water uses 785 like megawatts, like instantaneous power, these significant powers. So there's a ton of power usage, but one of the things you should do is run your stuff in a data center, managed cloud data center. Like, people don't seem to understand that, like, data center operators like Google, Amazon, etc. Like decades ago, 20 years ago, were already planning to put it here, both cheap, low impact, highly renewable power.
Yeah.
Too hard as a power source, but less power you need from distribution.
Good point.
Putting power over electrical lines loses power. Not a ton, but if you're only at the 7%, so that's power lost. Take the Google West Coast data center. Everyone knows about it. In the Dallas, Oregon, which is right next to a major hydroelectric dam. So they get all their power from that hydroelectric dam.
Yeah.
And with local agreements with that hydroelectric dam, and all the data center planners do that because for them, one of the most significant impacts or inputs is the price of power.
Yeah.
So no one actually runs like stuff at significant scale in LA.
Yeah.
Water usage of AI in LA. Oh, that was nobody.
Yeah.
Not to mention that, you know, the California Water Project delivered a billion gallon. I think.
Yeah.
Around that. So it's like, oh no, we may waste 2 million gallons a day. It's like.
You make a really good point. There's really been a big trend in data centers like a while they were trying to, because it was all about e-commerce and performance, they were trying to move data closer to the consumer. A lot of the HPC, the high performance.
Yeah.
It's not time sensitive, it's not lag sensitive, it's not
Yep.
sensitive. So they're sticking them way out in the middle of nowhere where it's cheap to run, cheap to power, cheap to land.
So I used to work at Google.
Yeah.
In both like circa 2006 and like, you know, 3-4 years like probably like insider. They never put the data close to the. Oh, they put data centers in the Bay Area to get you onto the Google network. And then still your Gmail and searches were being served out of like the mega data centers in the Dallas. I think the closest one now is like near Lake Fontaine. So they've been doing that for a long time. And Amazon, which I also work at, they ran their data centers out of, you know, their what has now become US form. They always run data centers.
Yep.
So they put them close, but like, you know, a couple 100 miles was like, you know, it was like a couple milliseconds on fire. So, you know, like putting a lot of like, you know, that was the big innovation of Netflix that made it work, is that they put edge caching in every single ISP that they did. It's like no one had to do it. And now there's but still, you know, that you know, it's expensive to put stuff in like that data center downtown wherever. And even if you're a, you know, super low latency trader, you know, and you're like, oh, I have to be right at the data center that's supposed to your stock exchange, you only put a tiny slice of your hierarchy footprint there because it would be exceedingly expensive. You know, cost driving stuff into efficiency. So, and you know, it's still, you know, like cost of pound and cost of pound in the area. So
Yeah, I mean, there's so many different aspects and so many different ways that we can follow the conversation. You know, to your point, Ron, like money matters, people will respond. So whether you gamify because you're trying to increase like your bottom line, or you gamify because you're giving like a bonus to the team who like has the biggest reduction in carbon footprint by percentage over the year, whatever it may be, you know, find the way to participate, find a way for for it to just be part of a conversation from time to time at an unconference, right? Just bring it up and just see what it is that any of us can do, because the conversation needs to be happening more. And, you know, why not start here? All right. Thank you all so much.
Broker code.
This is effectively the end of today's session. I want to thank all of you for staying with us all the way to the end.
Yeah.
This is Ron and my second event that we've kind of put together that's this large. So thank you for bearing with us as we figure out all the streaming, video recording, and all of it. We will have the videos available, posted online. We'll share all the slides with you. Please send us feedback so that we can kind of continuously improve. The first one we did was Global Encryption Day. So this was the first one this year. I can tell you this went, I think, a lot smoother and better than a Global Encryption Day. And you can expect our third one to even far surpass. At least I'm setting that goal and that expectation with everyone. The next event that we will have this year is Internet Day. That's going to occur around May. You'll get the specific dates if you're on our email list. It'll come similar form. So hope to see you there, and thank you so much.